Testing, testing. Hello, everybody. I'm going to be talking about Metatron, which is my open source project to create Ruby-based Kubernetes operators. Hopefully you're in the right place. Thank you all for being here. I'm Jonathan Gnagy. I am a staff production engineer at Shopify. It's the last you'll hear about my job, though. Primero una cosa. Déjame decir. Aunque mi charla va a estar en inglés, no se preocupen. Si tienen preguntas, me pueden hacer preguntas en español también. Bueno, si no entiendo algo, yo creo que alguien me puede ayudar. Bueno. All right. So here's the agenda. There's a lot that I'm going to cover, but it's worth it. We'll get through it. You're also going to see a nice live demo towards the end, so definitely stick with me. It's worth it. All right, so this is the big question. This is the thing that you're going to learn from our presentation, and it's going to keep you interested because you're going to want to know the answer to this question. It's the thing you're going to talk about afterwards when you're at parties, telling people about how awesome KCD was. What if you could extend Kubernetes? What if you could model complex things in a simple way that you can provide a small amount of information and get lots of work done? Wouldn't that be cool? Nobody's going to say anything, huh? Yeah, all right. Well, to be fair, that's already possible, right? That's definitely a thing. You can write some Go code, create your own controllers, and hope for the best. And when I say write some Go code, let's be fair, it's actually a lot of Go code. Even with the operator SDK, there's a lot of boilerplate. You have to write your own reconciler, you have to handle conflicts, you have to figure out how you want to update certain resources. There's just a lot of work that goes into it. And besides doing it in Golang, you could just pick your favorite language and use the Kubernetes client for that language and see how that goes. But in truth, most languages lag behind the features of Golang. Golang's where the main development for Kubernetes happens, and so you're going to get spotty results. There's certain things that just don't work as well in most languages. Things like watches, things like trying to handle scalability or even stability of your controller. It gets really hard. After all, we don't want to make controllers that end up crashing your Kubernetes cluster because they hammer the API because it was written wrong. So I guess what I'm trying to say is this isn't really the question that I'm asking. What I'm really asking is, what if you could extend Kubernetes in your favorite language with most of the hard work done for you? That sounds a little bit better, right? Well, for me, my favorite language is Ruby. So one more time, what if you could extend Kubernetes in Ruby with most of the hard work done for you? Well, good news, everyone. You can. That's why we're here at my talk, right? So let's get into it. So before I can really get into the good stuff and talk about how you can do things with Ruby, I want to build up a foundation to make sure we're all on the same page with what I'm talking about. So I want to cover controllers and operators and progress our way through what my code does and how it works with another piece of code called Metacontroller. All right. So Kubernetes controllers and operators. I suppose an even better question than the one I just finished asking is why? Not why Metatron or why my Ruby code to help you, because that still assumes that you want to do the thing that my code helps you do. In reality, what I mean is, why write an operator? Like, why would you want to do this at all? And for that matter, what even is an operator? What am I talking about here? Well, to answer that question, we really need to cover what is a controller. So let's dive into that. What is a controller? Well, a controller implements a control loop. That's probably pretty obvious, right? But it implements the control loop for the purpose of understanding the current state of your cluster, figuring out the difference with the desired state, and then acting on that difference to move your cluster towards the desired state. Sounds very generic, but in reality, that's what it is. Beyond this, the controller, it has a lot of different functions. It can do things like interact with cloud providers or create resources outside of your cluster. But for the most part, what I'm going to focus on are things that happen within your cluster. So, all right, I talked about a control loop. Part of that control loop has to be recording things. It has to understand both what your desired state is, and it has to have a place to record whether or not it was successful in migrating towards that desired state. So that for that, controllers interact with a certain type of resource. Deployment controllers work with deployments, stateful sets with stateful sets, or stateful set controllers with stateful sets. And these controllers can be built-in or custom. Obviously, they can be custom because that's what we're here going to talk about. But there's lots of built-in ones. I just named a couple, but there are lots of them. There's replica sets and daemon sets and everything else. Plus a lot that come from cloud providers too. So I really want to dig into what I meant by that control loop though. So here's a nice diagram of that control loop. Notice that there are different colors here for those different steps, right? Observe, diff, and act. I have an extended version of this diagram. It's a lot, so bear with me. I'm going to walk you through it. So these are, notice the colors. Hopefully you caught the previous colors. If you have a controller, it has different ways of observing the current state of your cluster. It can detect changes when you create one of the primary resources that it tracks. So like I mentioned, deployments, affecting deployment controllers. If you create a deployment, of course, the deployment controller has to know about that, and it knows it has work to do. You could also go and change something about one of the secondary resources that controller manages. So with deployments, when you create a deployment, the controller actually creates replica sets for you, and those in turn create pods. If you went and deleted the replica set, that's another event that controller will notice and have to reconcile the cluster and move you back to where it needs to be. Speaking of reconciling, that's the internal process within the controller where it is understanding the difference between your cluster's current state and what you said you wanted in that deployment resource. And then finally, we have the orange arrows, which are where the controller actually changes your cluster. So it updates the world, creates some secondary resources, could be doing all kinds of other things as well. And then it records status. There's a status field on those resources. If you ever inspect that, you can learn a little bit about what the controller is doing on your cluster. Hopefully this all makes sense. These aren't the only ways that a controller can observe your cluster. They're not the only ways it can interact with the cluster, but this is just a good general overview. All right, awesome. We know what a controller is now. We're all on the same page there. But what's an operator? Well, from a technical perspective, an operator is a controller that cares about custom resources. Seriously, that's it. That's the difference. It doesn't feel satisfying enough for that to be the explanation. I'm here talking to all of you. I feel like I need to do a better job. So, especially keep everybody interested. Can't have people walking out. So, I'm going to walk you through a thought experiment that'll make it all make sense. Like, why is it called an operator, for instance? Well, it implements the operator pattern. And what I mean by that is, imagine you're an engineer and during your day job, things are going well. You work with Kubernetes all the time. Your clusters all look good, dashboards all happy. Everything's going great. And so you're on your lunch break, and we all have to be thinking about our side hustles too. We've got other things going on. So you're on your lunch break reading your favorite book. And while you're reading your favorite book, you have a great idea. Like you're struck with, I've got it. I know the thing that's going to make me a millionaire. I'm going to build an app. And this app, it turns out, for my app to function, I need a backend system for it to work with too. I need an API for it to communicate with. So you start thinking, you're like, okay, what if I want to deploy my app and API, what do I need to do that? I work on Kubernetes all the time. You start thinking through, well, to deploy an app on Kubernetes, you're probably going to need a whole bunch of stuff, right? You're going to need deployments for your web servers, your job servers, what have you. Stateful sets, you'll probably want a database, maybe Redis, something like that. Some services, secrets, the list goes on, right? There's a lot of stuff that you have to create. These are all things that a human, a person approaching a Kubernetes cluster would have to craft and then kubectl apply or use a Helm chart or something else, right? But then you realize all of these things are kind of just components of something higher level. They're really just a way of saying, I want a web app, and these are the things that make up the web app. So I, as an operator, go create a web app by creating all these other resources. Well, there you have it. That is the model that we want to implement with an operator. So a Kubernetes operator does what a human operator would do in this case. So now we know what an operator is, and we had a better explanation. So why write an operator? Well, hopefully this one's pretty obvious. I mean, we all like having robots do our job. So let's automate the process so we don't have to do it. Let's make it easy so the next time you have another great idea, you just have to create another web app resource and all the rest is taken care of for you. It'll make it easier to iterate on your side hustles. So now we know what an operator is. Congratulations. I hope everyone has learned something from this. All right. So now that we understand controllers and operators, I want to walk through Metacontroller and how it works with my code, Metatron, to help you build operators quickly and easily. I've mentioned this before, but I feel like using Metacontroller is kind of like cheating. I am standing on the shoulders of giants. The people who built Metacontroller did a really great thing, and I'm going to walk you through why. So what is Metacontroller? It's an open source project created by Google originally and released as open source with the purpose of making it so you can create your own controllers without having to interact directly with Kubernetes all the time. So your code, your controller code, doesn't have to have, say, a Kubernetes client. It's crazy, right? What it does is it handles those Kubernetes interactions for you. By that, I mean, if you remember on our diagram, there were lots of things that your controller had to do. It had to interact with Kubernetes and understand the current state of the world. It had to make changes. It has to run that reconciliation, all that sort of stuff. Well, Metacontroller's job is to take care of as much of that for you as possible. Your code really just needs to handle some hooks that Metacontroller interacts with. So Metacontroller is looking for API endpoints based on certain types of controllers you might create. It's looking for an API endpoint to send some JSON data to about the current state of the cluster. And then it's expecting a response back with JSON to tell it, here's the desired state. So let's dive into that a little bit more. Here we go with the diagram again, but it looks a little different. The solid lines there are the things that Metacontroller handles for you. It handles the observation of your cluster, and it handles the actual acting on your cluster. And it even does a little bit of the diff part for you, but it defers to your code to help handle the bulk of it. So let's look at the expanded view again. This diagram looks almost identical except for the bottom. We can see here we've created a composite controller through Metacontroller. I'll get into that in a little bit, but it's basically telling Metacontroller, hey, I have a custom resource I want to track. And here's information about that custom resource. Tell me when you notice changes in the cluster. Tell me about those changes so that I can tell you what to do. So you see in the bottom, there's a little diamond shape for your code. And you can see that Metacontroller will send a sync request to your code, and it expects a response back. This is where Metatron lives. That's where my code will come into play. The idea is Metacontroller makes it really easy. Just understand JSON, provide some JSON back that describes what resources you want to exist in the cluster. Those resources can be anything that the cluster understands, so they don't have to be built-in resources. They could in turn be other custom resources, even controlled by other metacontroller controllers. And yes, I said metacontroller controllers. All right, so how does my code help? I just told you about how awesome metacontroller is. Well, Metatron helps by being batteries included. And what I mean by that is it's a rack app that is very easy to deploy, very easy to get started with. It comes with JSON parsing and JSON rendering for you. It gives you helpful hints about information coming from that request so that you can use it right away. It includes neat features like eTag support, so it makes it really easy to have efficient communication between Metacontroller and your app, and more. There's a lot of other features as well. It's also really easy to embed, both in Rails or in Sinatra or whatever your favorite Ruby web framework is. Specifically for Rails, I built it to be very easy to embed in an existing Rails app. So you have a control plane, it already does things for your infrastructure, but now you want it to start creating Kubernetes resources? Well, great. You can embed a Metatron app in it and get started pretty easily. Since it has a rail tie, it's actually basically just require the gem, bundle install, create a controller and mount it at some endpoint, and you're good to go. Metatron's own API is meant to be super simple. It's really meant so that you only have to define one method on your controller. That's it. Now, obviously, as a good developer, you'll probably break that down into smaller pieces. But the end result is the actual, if you think of it as an abstraction, the requirement is that you develop the proper method for, say, that sync endpoint. You just write a sync method, return some JSON, and you're done. You can optionally provide an eTag calculation method too that helps inform Metatron how to go about calculating eTags, assuming it's different than having to do the full sync process. The idea there being that if nothing's changed in the response, Metacontroller can quickly move on without having to wait for you to render the entire sync method. And there's lots of reusable templates. This is a big part of what makes Metatron awesome, is I've written templates for basically every built-in Kubernetes resource. There's some that I haven't gotten to. I haven't had any issues or requests for them. I do use Metatron at work, and it's covered everything I've needed on my team. I have had contributions from other people in the community, which is nice. But those templates are meant to make it really easy. No, it's not a DSL, but yes, it is Ruby classes that you instantiate and provide information to. And there's more features under development. In the interest of time, I'm going to move along, but trust me, I'm still working on it too. We made it to demo time. All right, I'm going to put this down. Let's see if I can do this. I'll put this down, hang on. Thank you. All right. That was awesome. Okay, so here I have my cheat codes, which are what I'm going to be copying and pasting into the terminal here. Let me make these larger. Oops. Is that visible for everybody? Good? Yeah? All right. All right. And this one too, or should I make this larger? There? Good? Okay. Cool. Yeah, don't worry, the cheat codes are my notes, but really the important part is what we're going to be doing is creating an actual controller, an operator with Metatron and deploy a database. I work on databases at work, so I figured naturally what I'll do is I'll create a MySQL database and log into it. All right, so I'm going to just copy and paste a couple things into the terminal. This is nothing too interesting. I'm CDing into the directory where this code is. And now I'm going to install Metacontroller. I don't recommend doing it this specific way in production because this is just installing some stuff right from the internet. Generally, you want to download these things and understand them first, but I'm feeling pretty confident about how this works. Okay. And let's make sure Metacontroller itself is working. Okay, cool. Metacontroller is up and ready. So now I'm going to create my custom resource definition. As I mentioned with operators, they care about custom resources. You have to define the schema for those so that Kubernetes or your controller understands how to interact with them. So here I have a custom resource definition. Really, there's nothing special about this. This is the same as if you were going to create any other operator. You give it a name, give it some details for the actual schema. So here the schema is pretty straightforward. There's a status field, and then with a spec, I say specify a container image to run and some quick details about resources, just so that we have something to look at. Okay, so let's create that. All right. I did some of this work before, so that's why sometimes you see it says no changes. Okay, now we're going to create the composite controller. So this is the part where Metacontroller comes in. It's not very much here, right? I think it all fits on one screen, looks like it. So we're going to create a Metacontroller composite controller. So if you remember from the diagram in the middle, that's what we're creating. I'm going to call it database controller because that's what I'm going to create, databases. So you define a parent resource and then child resources. So in the context of the diagram that I showed, primary resource, parent resource, that's what that is. And then the child resources are the things that I anticipate my controller creating. And so we need to pay attention to those and establish a relationship. So it'll put an owner reference and other things for you. So for our database, I expect to create stateful sets, services, secrets. I think that's good enough. At the bottom here is probably the most important part. This is where I'm telling Metacontroller that whenever you see a database, talk to this endpoint. Here's the URL. Perfect. Thank you. This is the Docker host on my machine, so that I'm going to run the process directly on my Mac. All right, so let's go ahead and create this. And I'm happy to put this all on GitHub in the end. I don't know if I'll have time today, but if you check my GitHub profile, which there's a link to at the end, you can find all of this. Okay, so we've created the composite controller. So now Metacontroller knows to watch out for databases, and it knows what to talk to whenever it finds it. So now we're going to look at the code that I wrote in Ruby that uses Metatron. First, some boilerplate stuff. This is like any Ruby project. You have to have a gem file for your dependencies. Here, the dependencies are pretty light, right? I've got Metatron and Puma. You don't have to use Puma if you have some other preferred Ruby web server, but I'm a fan. Most of the community is. I recommend it. And then there's the rackup file, so the configuration for how Puma should understand what to run, basically. We require Metatron. We require the code that I'm going to show you in a little bit. And then we mount the controller that we're going to create at /databases. So if we look at the composite controller we created, the URL ends with /databases/sync. And so this is where we're just saying mount my Metatron controller at /databases. The other files, like I'm specifying what version of Ruby to use, some style-based stuff in Rubocop, if you're familiar with that. All right, but all that boilerplate out of the way, here's my code. Really quick just to see, it's 59 lines with comments and white space and everything else. Not that measuring code is that important, but it's not a lot. If you're trying to write your own controller, it would usually be a lot more than that. So here I'm creating a subclass of Metatron composite controller. Usually you wouldn't have these as constants, but just to make it simpler, I'm just saying let's set some variables with some passwords, and we'll use those to provide the secrets and configure MySQL, that sort of thing. So here is the method that we had to define, the sync method. I broke that down into a couple smaller methods just to make it easier to understand, but the sync method is expected to return a hash. And one of the keys on that hash is status. So it's basically after evaluating the current state of the cluster, the expectation from Metacontroller is that you say, here is the status of that cluster based on what you just told me. After it does what you tell it with the desired state, it'll respond again and say, now the current state seems to match the desired state. And then you can update status again with something else. Just to keep it simple though, I just said set status to syncing is true. So params is the thing that Metatron gives you to work with the request. So the request body comes in and is parsed, and there's a parent key, and then there's also some other data within there. But really the main thing to worry about is the parent. And the parent, remember, is the resource type that we're talking about. So in this case, when you define your database custom resource and kubectl apply that, anything that's on that resource is what gets sent in this part of the hash. So what we need to do is construct some desired children, basically the desired state, and return that. So we create a secret, a stateful set, a service, and then we send them along. Very quickly, I will run through what this looks like, but here's some examples of the actual code. So to create a Kubernetes service, this is the code to do that. You tell it the name of the service, the port that it's going to run on, and you can optionally tell it here's the selector labels to use for your service. When you're going to create a secret, equally easy, right? You say, I want to create a Kubernetes secret. Here's the name of the secret, and then you give it key value pairs for the data that goes inside the secret, and that's it. Stateful set's a little bit longer, but there's more that goes into that. We describe the image, and we get that from the spec on the parent. So we pass in the parent's, basically that custom resource, there's a spec. And in that spec is where we said, here's the image and some resource information. That's passed into this method. So it's saying, oh, it looks like you want to use this image, and if not, fall back to MySQL 8. If you specified memory, great, use that. If not, fall back to these. Obviously, like if this were production code, I would do validations here. I would try to make this code resilient to bad data. But for now, this is good enough. And then we define a container to actually run for our stateful set. So we create the stateful set, define a container, add the container to the stateful set, and we return it. That's all the code that my controller has to run. So let's go ahead and kick this off. So bundle install is just to install the Ruby dependencies, and then I executed Puma. So it's listening on port 9292. Let's test it. Let's make sure this is actually working. So I'm going to grab a curl command, open a new tab, make the text bigger, paste in my curl command, and here's the JQ output. Here's all the data that my controller responded with. There's the syncing true in the status field, and here's all the different resources that are going to be created. Just because I want to keep measuring things, let's get a sense for how much, 102 lines. So my 59 lines of Ruby provided 102 lines of JSON data. So I think that's a win already. All right, so let's go ahead and actually create a database now. We're almost done. Let's create a namespace. All right. And I'm going to apply my custom resource. And here's the contents of that custom resource. I'm going to create a database. I'm going to call it my app, and it lives in the namespace my app. It's going to run MySQL 8, and here's the resources that I wanted to use. Hopefully no surprises here, right? So let's go ahead and apply this. Oof. Uh-oh. Oh, because I'm not in the right directory. I opened a new terminal. Always something goes wrong with demos, right? Hopefully that's it, though. Okay, so I created my database. Yay. Let's see if it's working. Let's grab this. We can ask Kubernetes about databases. There's one. Not very informative, but it exists. And now we can check for stateful sets. This is where we should see a database that's ready, and it's 20 seconds old. And we can finally check the service. And we need the service because I'm going to grab the IP, and I'm going to use this to actually connect. I'm going to launch a Docker container, and I'm going to try connecting to our new database. There we go. So here in the actual command line, I included the password, so that's why I didn't have to type it. But I can say, let me put this down. And there we have it. There's a my app database created in a running database container on Kubernetes using Ruby. All right, almost done. Let me get back to the presentation. I can stand now. I feel like we're not appreciative enough when demos go well. I mean, I'm a little biased right now, but I've seen so many good demos today. I know, right? All right, so let's recap very quickly. Operators are controllers that implement high-level concepts. So in this case, I implemented a database and all the pieces required. Metacontroller allows you to create operators in any language you'd like. Metatron makes it easy to do that in Ruby. Time for questions.
Uh, just one question. Um, your templates are a bunch of Ruby classes that know how to talk to Metatron, and then they do the magic.
I can show you the code for that maybe after, if that's okay. But the Ruby classes only know how to generate hashes. That's all they do. They render to hashes. They have every one of my templates has a render method, and Metatron itself is smart enough that when you provide it a hash with desired children, so all of the desired state, if any of those respond to the render method, it calls render. So it kind of like renders them at the very last second to actually turn them into Ruby hashes and then finally into JSON. Cool. All right, well, here are some links as promised. To the left is the wiki for the actual Metatron project. So it's the GitHub wiki. And on the right are the Metacontroller docs. I feel like it's worth mentioning those. Even if you don't love Ruby like I do, hopefully you're at least inspired by the idea and say, maybe I could build something like this in some other language that I like. Metacontroller has lots of great examples. Sadly, they didn't have a Ruby one, but they have some for JSON, for Python, for all sorts of other languages. So I think they even have one in Bash. So it's pretty much anything. Cool. Well, if there's no other questions, awesome. Thanks, everybody.